Video lesson 9.8, Law of Sines. So let's just go back to thinking for a second, dealing with this right triangle. So if you look at this do now question, we have triangle ABC, which is a right triangle, and angle A is 55 degrees, and it wants us to find both AC and BC. So let's take a second. We're looking for this one first, and then we also want to find this one over here. So again, using my trig functions, we can find these values. So we're all going to be dealing with, in this case, with respect to the 55 degree angle. So with respect to this, across would be opposite. Across from the 90 is, that's a terrible arrow, is your hypotenuse. And then that would leave the third one as your adjacent. So if I'm looking for this first one, I'm looking for, according to SOHCAHTOA, I want the adjacent side, and I have the hypotenuse. So that means we're dealing with cosine. So cosine of the angle, in this case, cosine of 55, has to equal adjacent, which we'll call this x. So x over 8.5. Once I have that, put it over 1, cross multiply. We're going to get x equals 8.5 times the cosine of whatever 55 is. For this case, let's plug that into the calculator. So we've got 8.5 times the cosine of 55. Again, make sure you're in degree mode. And it wants us to nearest tenth, so this is approximately 4.86. I'm sorry, 4.88. Sorry, 4.88 for that one. So that's our length of the first side. Let's do it for the second one. Here, again, with respect to this, that would be opposite now and hypotenuse. Again, I could technically use this side that we just found, but I'm going to stick with what I know for a fact is true. So I'm going to use that part. And since we already used x, let's use y to find this. So that in this case is going to be sine. So sine of our angle, so sine of 55 is equal to opposite, which is y, over the 8.5. So now I can put this one over 1, cross multiply. So now this side is just going to be y is equal to the sine of 55 times, I'll put that first, so 8.5 times sine of 55. And if we plug that into the calculator, we get approximately 6.96 for that side. There. Now again, as we've discussed, I could have found y. Once we found x, I could have found y by using Pythagorean theorem. All right. Again, you've got options. It kind of works out to whichever version you'd like better. I like to kind of go back and use the information I know for a fact is correct, just in case I made any errors or anything. But again, all should work out the same. So trig proportions are used to find measures of missing sides in right triangles, as we've discussed. But we could also use trig to find the missing sides of non-right triangles. All right. Now we can't use the SOHCAHTOA because that, as we discussed, it has to be using a right triangle. But we do have other rules, and this one is law of sines. So you have here 3 ratios, all being said that they're all equal to each other. We're never going to use 3 at the same time. You're only going to use 2 of them. But the key thing to note is what the little letters A, B, and C represent the sides, right? So each of these is like a side value. And the big A, B, and C are the angle values. All right, so that's important to know. So when we have this information, we can utilize the angles and their sine values and the relationship they have to their corresponding sides. One of the things that you have to be careful about is the setup, and the sides are across from the angles. So for example, side A, so little a, is across from angle A. And then little b would be across from angle B, and so on and so forth. Okay. So there's 3 scenarios where you're going to be able to use this kind of work to find the non-right triangles, right? First is looking for a side where you're given 2 angles and a side. So you essentially can think of angle, side, angle. The other one is looking for a side when given 2 angles and a side next to one of those angles. Again, think angle, angle, side. And the third one would be looking for an angle who's given 2 sides and an angle next to one of those. Think side, side, angle. From there. So for us in this time period, the first and the second are things that you're going to see. When dealing with the third case, not at this time, but it is something that can be done using the trig. But for right now, these first 2 scenarios are going to be the ones that we're going to work out. All right, so let's actually do some of this, because I think once you kind of do them, I think that makes a lot more sense in this process. So in triangle ABC, right, little b is 3, angle B is 25. So again, notice angle B, across from that would be little b. And angle A, across from that would be little a. And angle C, across from that would be little c. So you got 2 angle measures, right? We're looking for a side. And I've got the angles and the sides across from each other. So, example here, I got angle B, that produces this side, which is little b. And then I've got this angle, angle C, which produces this side, which is C, which is what we're looking for. So if I make a ratio out of those, so I'm going to do 3 over sine of 25. That would be equal to the ratio of the C side, so C over sine of 70. So again, I only going to have 2 ratios. I know that over here it looks like 3 of them, but I can't have 3 things equal in an equation. Can have 2 sets of equal sides. So we're just saying that these 3 ratios are all equal to each other. So I'm only ever going to use 2 of them at one time. Once I have them, notice this is just a proportion. So now I can multiply. Cross multiply here. So I'm going to get C times the sine of 25 equals this cross multiplication, which is 3 times the sine of 70. Now I'm going to hold off. Again, as you guys know, I've liked to find the solve for the variable all by itself and then worry about plugging in the calculator. So if I'm at this point here, I'm going to say, let me divide out this sine of 25 from both sides. All right, get this alone. So now I have C equals 3 times the sine of 70, all divided by the sine of 25. All right, and now we're going to plug this into the calculator. All right, from there. So let's plug this part in. We've got 3 sine of 70. Get that answer, divide it by the sine of 25. And this whole thing is equal to 6.67050, blah, 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 blah. What did it ask us to round to the nearest whole number? So that's going to give me approximately 7 for this one. So you see how we were just able to find that value, even though I do not have a right triangle. Right, which is nice, because otherwise I'd have to like break this thing up and make it into like, 2 triangles, having right angles, and that would just make things a lot more work and annoying. So find TV to the nearest tenth, for example number 2. So once again, let's break down our parts here. So I've got this angle, which is T, so across from that is little t. And then I've got this angle of 125. I need that to be this side, which will match up. So this is little m. So let's make our proportion. So I can do m over the sine of that angle. So sine of 125 equals the side, which is 6, across from the sine of angle 25. Once again, Now that I have this, I can cross multiply. We're going to multiply out. So m times the sine of 25 is equal to 6 times the sine of 125. Again, isolate your variable. So we're going to get rid of the sine of 25. So m equals 6 times the sine of 125, all divided by the sine of 25. Let's plug this into the calculator. I've got 11.629673, blah, 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 blah. And they asked us to round to the nearest tenth. So it's approximately 11.6. Again, I don't have units, so in this case, just 11.6 is fine. So again, nice little formula here to use. Very helpful, especially since trig, all the stuff we've been talking about, all required a right triangle for SOHCAHTOA. This is a nice little opportunity to kind of make things a little easier for yourself and find values when you don't have a right triangle. All right, let's look at a couple more examples here. All right, so we're looking to find side B to this nearest integer. All right, so again, it's all about setting up the relationships. So here, we've got 34. That's across from B, so that works. I have 80, which is here, and that would be this side over here. But I don't have that value. But I do have this value over here. I do have A is 16. But that goes across to this angle, and I don't have that angle. So I do have to kind of think a little bit outside the box here, right? I got to kind of work backwards a little bit. I got to find that angle first in order to use it, right? Because I'm okay with putting B over the sine of 34, right? Those match up. Those are across from each other. So that's fine, but I don't have here. This side of 16 has no relationship to that angle of 80 degrees. But I got to find the other one. So to find that other one, right, first over here, to find this, simply say, well, in the triangle, all three. So angle A plus 80 plus 34 all have to equal 180 degrees. So 80 and 34 is 111. If I take that away from 180, angle A is going to equal 66 degrees. So now I know that this is 66. Now I have a relationship with sides. So now I can say that 16 is equal to the sine of 66. And now I can use law of sines. So just a little extra part there, but again, nothing dramatic. Just got to have to know that you have to do the little extra work there. So B times the sine of 66 is equal to 16 times the sine of 34. We're going to divide each side by sine of 66. So ultimately, B is going to equal 16 times the sine of 34 divided by the sine of 66. And if we plug that into our calculator, we get 9.793805, blah, 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 blah. Finds the nearest integer, approximately 10 units long. All right, so a little extra tricky part there. Kind of have to do a little work off to the side, but again, nothing overly dramatic. All right, determine the little b to the nearest thousandth. So again, we're looking for little b. So that's across from angle B. This would be little b. All right. So we don't have that angle. So again, I need to find that angle. So here, we'll do this off to the side. So we'll do angle B plus 37 plus 92 all has to equal 180. So if we do that, what's 37 and 92 would be 129. If we take that away from 180, that would be what, 51? So that means angle B is 51. So now I can say b over the sine of 51 has to equal, and I have this side, so I want to use this angle, so 9 over sine of 37. Now I can cross multiply and solve. B times the sine of 37 is equal to 9 times the sine of 51. Divide each side by sine of 37. So B equals 9 times sine of 51 over sine of 37. Let's type that into the calculator. I get 11.62203, which is approximately 11.622 nearest thousands. Yeah, it's that thousands instead. And we're good to go. All right. How about this next one here? So we're given this scenario where the ski lift begins at an angle of 20 degrees for 0.75 miles from the base of the mountain, whose face is 50 degrees angle of elevation. The ski lift ascends in a straight line at an angle of 20 degrees. Find the length of the ski lift from the beginning of the ski lift to the top of the mountain to the nearest 100th of a mile. For there. So, here. All right, so we got to find these pieces. Now, ultimately, we're looking for, we're ultimately looking for this length here. So that's going to be my x, which means I need that angle. So at first I don't have it, but I notice I have an angle that is supplementary to it. This angle here. These two angles, right, together make this straight line, so these are supplementary angles. So 180 minus 50 is 130, so now I have that. And the other thing it tells me is the ski lift begins at ground level 0.7 miles from the base of the mountain. So now I know that this part here is 0.75 miles. All right, which means I need this angle over here. So now that I know this is 130, right, I can say 20 plus 130 is 150, minus that makes this one 30 degrees. All right, so now I have relationships and their sides, so now I can make my law of sines proportion. So x over the sine of 130, that has to equal 0.75 over the sine of 30. We can cross multiply now, try and solve here. So cross multiply, I get x times the sine of 30 is equal to 0.75 times the sine of 130. We're going to divide each side here by sine of 30. So x is going to equal 0.75 sine of 130 over sine of 30. Now, sine of 30 is one of those special angle measures, so if you do know that one, you could plug it in for that one, but which is a half, but I don't know sine of 130, so I'm still going to have to use a calculator, so I'm just going to plug it all in here. So 0.75 times the sine of 130. You get that answer. Then we're going to divide by sine of 30, which, like I said, is a half. So you're just really getting that to be 1.14906. And it says nearest 100th of a mile. So it's approximately 1.15 miles long up the ski lift. So again, had to work around a little bit, had to come up with this angle measure over here. Again, we did that by saying, 180 minus the 50 got me the 130. Then I was able to use that to find the other angle, which was 30, so on and so forth. All right, one last one, and then we'll wrap this up. This one's a little bit lengthier, a little bit more involved, a little bit more crazy looking, but again, law of sine is going to make this a lot easier for me, or shorter, I should say, in the grand scheme of things, right? But I could, I could do this using just regular trig as well. But let's kind of work through this here a little bit. So my goal here is to find the height of the flagpole. So my goal is to find this height here. All right. So at first, looking at this, right, I say, okay, just a regular trig question, right, and solve for that. But I don't have a lot of information here, right? I know that I've got the angle measures, right? And then it tells me the survey instrument is 1.7 meters tall, and these two spaces between each other are 8 meters in distance here. So I got to come up with a way to find that value out. So, like I said, you got a couple options, but using law of sines, we can come up with the missing pieces, and then allows us to kind of work backwards to find the parts that I'm looking for. So we're first going to kind of find this piece here, right? So with that would be the side associated with this angle. So let's call this x. So I got x over the sine of 34.9 equals, right? Now I have this side here. Let me do a different color. I've got this side here of 8 meters, which means I would need this angle over here. So I got to do a little extra work here first. So I can find this one here by saying the supplement of this. So 180 minus 52.8 degrees, that's 127.2. So now all three of these have to add together and equal 180. So 127.2 plus the 34.9 is 162.1. And if I take that away from 180, I get this angle over here to be 17.9. So now I have my angle and the side it's across. So 8 over the sine of 17.9. Now I have something I can solve. Cross multiply, right? X times sine of 17.9 is equal to 8 times the sine of 34.9. So if I isolate the x by dividing it by sine of 17.9, x is going to equal whatever this calculation comes out to be. Now, I'm going to hold off for a second here because that's going to be a big decimal, right? You could find it, it's fine. But when I do this here, actually here, you know what? I'll just plug it in real quick just to show you here. So sine 8.5 times the sine of 34.9, divide that by the sine of 17.9, right? We get this decimal here of sorry, let me try that again. 8 sine of 34.9 divided by sine of 17.9. Nope, that makes more sense. So I get 14.89203, blah, 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 blah. So I'm going to carry that around. So again, I'm not usually a fan of just having to write the decimal out over and over and over again, but I would have carried the whole term over, but it doesn't matter here. I just don't want to round this off yet. That's the key. So now I've got this answer. Now I've got this blue portion here. So this right now is this, again, this portion here. So now I can use that to find my actual side here. So this part here, let's call it y. So I'm going to say this portion right here is y. All right, so with that, we can say now with respect to this angle, this is opposite, and this x side that we had, that was our hypotenuse, right? And then this would have been the adjacent side. So now I can just use regular trig and say, well, opposite and hypotenuse is sine. So sine of 52.8 would equal y over the angle that we just, the measure that we just found, 14.89203, blah, 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 blah. Again, remember, this is just a portion of the answer. I want the whole thing, which is in my calculator. And now we're going to divide this, put this over 1 and cross multiplying. So y is going to equal that whole number, the whole decimal, times the sine of 52.8. So if I take that answer and multiply by sine of 52.8, I get y to equal 11.861955, blah, 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 blah. And now be careful, that's not my answer, which is what everyone wants to say, right? Well, why isn't the answer, right? It says because here, that's only from here to the top of the flagpole. We have to include this little portion here, which is the height of the survey stick. So I got to add 1.7 meters to this. So I add 1.7 meters, I'm going to get the flagpole to equal, and again to the nearest tenth, approximately 13.6 meters tall. So a lot going on there, obviously a lot more involved, but that's the kind of thing that we got to get ourselves to, because those types of questions can show up on the Regents. They're going to be, like your part 3s and your part 4s, but again, we got to be able to utilize it. So a lot going on there. So I do recommend just maybe, pausing the video or rewinding it, kind of going over that a little bit more again, giving it a try. And don't forget to utilize the practice problems for more reassurance.